Excellent. So let's do some math. This is math 207. We were in chapter 2. And this was on multiples and fractions. So I'm going to say 2.1b because I was in 2.1. And we went over divisibility rules. Like if you look back through your notes, we saw divisibility rules. And we showed a little way of how to get prime numbers. Called the sieve of Eratosthenes. But the prime numbers, at least the first few, are 2, 3, 5, 7, 11, 13, 17, 19. Let's see, we got 23 and 27, 29. Nope, 27 is not one.
What does it say?
31, there we go. Let's see, 32, 33, 34, 35, 36, 37, 37 is one. 38 is not, 39 is not, 40, 41 I think is, and so is 43. And you can keep going up and through them. It's not important to know, but it is something to note that every once in a while, they're 2 away. And the further you go down the rabbit hole, the more spaces there are before they're 2 away, but it's not important. It's the important thing is prime numbers aren't divisible by anything else. And if you're getting a prime number higher than 43, I don't know what you're doing, what you're building, but it's probably like a skyscraper or some shit like that. And you're going to have someone that's a really good engineer doing that shit. So let's take advantage of the prime numbers and let's look at a prime factorization. I don't know if I started this or not, but we're going to start it here. A prime factorization is you start with a composite number, which isn't prime. And determine and find all the prime numbers that multiply to make it. I don't know if the words help you. Some people it does. For me, it doesn't help a lot. The actual process does, but I'll give you a second to write it down. Not very loud. Oh, there it went. There's a little squeak. So let's do 24. Does anyone know 2 numbers that multiply together to make 24?
Two and 12.
2 and 12. So I'm going to write them down. I'm going to make this little tree. 2 is a prime number. That's over here. 12 isn't on that list, which means 12 can be broken down itself.
22.
2 and 6. 2 is a prime number. 6 again is not on the prime number list, but that one we're getting kind of easy. 2 and 3. So the prime factorization of 24 is 2 times 2 times 2 times 3. You can also write that as 2 cubed times 3 if that helps. By the cube part, remember the exponents comes from how many 2's we have. That gives me my exponent. That's not the only way to get it though. If I had done 24 and I had started with 6 and 4. Well, neither of those is prime. So those break down. 6 is 2 times 3, and 4 is 2 times 2. And those are all primes. And notice again, I have 3 2s and 3. So it doesn't really matter what order you do it in, like just pick numbers that you know multiply together that make it. I strongly recommend knowing the basic multiplication table of up to 10 by 10. If you need to if you don't know it, make flashcards, like what's 9 times 8, have on the back 72, until you have it memorized. Because you shouldn't need a calculator for stuff that I was taught how to do in like 3rd grade or 4th grade. There's no reason for it. You guys can memorize it. You can do it. It's just memorization. Not even doing math at that point, it's just memorization. So let's have you guys try one on your own. Try doing 60. Start with 60 and break that bad boy down and see what you get. And we'll do it together in a couple minutes. What'd you do this weekend, Bob?
Went to a Supercross race down in Anaheim. 9 people got front Santa Monica and was 8 hours.
Nice. I attended Job Corps in Los Angeles. It's in downtown Los Angeles. And the honor dorms were in Hollywood. And on the weekends, we would take the bus down to Santa Monica. It was like an hour-long drive, but we'd go every weekend. It always went right by a Lamborghini dealership. So we'd be sitting on that side of the bus just going, yeah, I want one of those. I still want one of those, but I need to lose weight before I can get one. And I need to make a lot more money than I do.
In the used market. Sometimes
Say it again.
2 times 2 times 3 times 5.
Yeah. So everyone done? All right. So what 2 numbers did someone start with?
6 and 10.
6 and 10 is an excellent choice. That would be my choice. Whenever I see something ending in 0, I know it's a multiple of 10, and that's an easy breakdown. It makes the next part a lot easier. If we could have done 2 and 30, but then 30 I got to do more work with. 6 and 10. Well, I know 10 is 2 times 5, and I know 6 is 2 times 3, and those are all prime numbers. So 60 is 2 times 2 times 3 times 5. And there's a reason why I'm writing it out like this, not using exponents. I'm going to show you guys in a second. Because oftentimes we want to find something called the least common multiple. And it's usually abbreviated LCM. And we'll also do greatest common factor. That is also something that is useful. GCF, it goes off the first letter. So we're going to do both of these before we start diving into fractions. So, least common multiple is the smallest number that two or more numbers is a factor of. And I'm going to use the 60 that we just did as an example. If I want to find, let's find the least common multiple of 6 and 10. Those are two numbers that are useful. It's not going to be 60. So what a handy way of finding these is to take each one and do a factorization. 6, we already did this. 6 was 2 times 3, and 10 was 2 times 5. If you make a table, so this is Hefe's table. I thought this shit up while I was in the shower, like 5 years ago, that someone wasn't following how they, like every other way that people taught. And this works great. And I realized how many different things it works for. Hopefully, if you give it a try, you like it. What we're going to do is we're going to write down both the numbers we start with. And we're going to write the first one's factorization. 6 is 2 times 3. So write the first number's factorization. Factors. Now, for the next number, and all numbers, if we're doing more than 2, write the factors down where columns match up. Where everything in one column is the same. Making a new column if you need to. So 10 was 2 times 5. I need to write 2 in there. I already have a column for a 2, so I will put the 2 underneath it. I do not have a column for the 5. I will put the 5 in a new column. That's what that sentence right there meant. Do something like this. And maybe put some. All right, so the LCM is just bring down the number from each column and multiply them together. Two times 3 is 6. 6 times 5 is 30. The least common multiple of 6 and 10 is 30. And we'll use the same one to show greatest common factor. Greatest common factor is the largest number that divides evenly into the numbers you're looking at. Conveniently, the setup is the same way. I'm going to redo it just so that it's not messy. Setup is the same. But that's where we stop. We write all the factors. The GCF is the completely filled columns. Multiplied together. Pretty quick with numbers, Bob. Are you taking these classes for credits or something?
Yeah, pretty much.
You're doing the factorization without writing anything down. Like, it's a good skill. All right, so the only column that has numbers in each row is the 2. The GCF is 2. All right, let me give you guys one to practice on. That's small, and then we'll show scaling it up. Find the LCM and GCF of 28 and 35.
Right, if you're stranded on an island. You got one video game. You can bring it with you. And you have internet,
And I have internet.
but you can't contact people that are stranded on islands. Very
I'm like,
convenient.
why would I be playing a video game? I have the internet. I'm fucking getting off the island.
So you can play the online version.
It's gotta be something that's simple, because even games like Dark Souls gets old. I don't want to play the same shit over and over.
Then Minecraft.
I have not played Minecraft, so I couldn't answer that.
What?
I haven't played it.
I don't play video games, but that's the one video game I play.
That's because it was very, very, very popular when you were a teenager.
Yeah, it was like
When I was a teenager, it was not popular. So maybe Candy Crush or Tetris or something like that, something simple that's,
you could like come back here.
yeah, I can play for a little while and then, like hunt boars and whatever.
That way you're not playing the same level and you get way too
Yeah,
good.
exactly. What would you do?
I mean, yeah, I don't know, deck of cards. You could use them, but-
That's not a video game.
I know, video game.
You
I don't play
fucking
video
cheat.
games very often. Probably Forza, that's always fun. I like the different cars you can drive around.
Oh, like, okay. That would just make me feel even more isolated.
You're like, no, I can't even drive that.
Let's go put a Lamborghini you want, like it.
Yeah. There you go.
Right, you're like, I could be free or I could be stuck on this fucking island. Let's play a game where I'm fucking free and just wish I was on this island. I know what I'd play. I'd play like boat making simulator.
You get
Right?
good at driving and making a boat.
You gotta make it a boat and then apply it to fucking getting off the island. Yeah, I use the thinker.
Titanic 2.1.
Wait, what? Titanic sunk. All right, so let's do find these factors.
Second one's easy, the first one.
What multipliers I gotta make 28?
7.4.
7 and 4 is from the multiplication table. That's a good start. 4 is not a prime number, but 7 is. And 4 breaks down into 2 times 2. 35 is also on the multiplication table.
7.
7 and 5. So what I'm going to do is I'm going to do my little table. And I'll start, it doesn't matter which one you really start with, as long as you're consistent. 28 has 7 times 2 times 2. 35 has 7 times 5. Now I'll make a new column for 5s. So I can see right away the GCF is the only filled column is the 7. To find the LCM, I'm going to bring 1 down from each column and multiply these together. Now, that's a lot to multiply together, but we don't have to go left to right with multiplication. I know 2 times 5 is 10. If you see anything in there that ever multiplies to 10, it's a good spot to start because it makes the next part easy. 7 times 2 is 14. So 14 times 10 is just add a 0. So 140. If I were to go left to right, I'd have 14, and the 14 times 2 is 28. And then 28 times 5 is going to make me stop and think a little bit. And it's going to make a lot of other people just grab a calculator. But I didn't need a calculator the way I did it. I generated stuff that's on the multiplication table. So that's how we find it for 2 numbers. Let's kick it up a notch. Bob thinks he knows what the hell he's doing.
I hope so.
Let's see if Bob knows. Find the LCM and GCF of, let's do 36, 48, and 60. Scaled it up. You might be able to do GCF pretty quick. He's good with numbers.
That one's easy. No, it's not. She made them all divisible by 12. It's way too easy.
What is it?
I'm trying to slow it down. There's a lot of numbers involved.
Now, don't pull out your phone. Let's see what you do without your phone.
No, I have to.
No, you don't. Oh, okay. Excellent. That's the point. Make you learn something. This is useful.
Well, it's more like it's more numbers. I can't do 3 numbers.
I did. Then again, I am a mathematician. It's cheating. I think of another one again here. So you might actually not like this method when it's done, Bob.
Oops, sorry.
Because you're right now, you're going with the guess and check. Looks like rather
No,
than
because I don't understand where.
All right, so let's start factoring and see what we get. What's 36? What's the 2 numbers that makes 36?
You could do all, yeah, let's do them all.
I don't want to do that for a reason. I want to show that I want to show how it falls out from the table.
Oh,
But if you recognize that, do what he just said. 12 is going to be the greatest common factor, but if you don't recognize that, it doesn't help you to start there. So 36 is 6 times 6, and then those break down. 48 from the multiplication table is 6 times 8. This multiplies to 2 times 3. 8 is 2 times 4. And 4 breaks down to 2 times 2. And we did 60. 60 we had is 6 and 10, and 2, 3, 2, and 5. So what I'm gonna do is I'm going to write those up. And I hope I gave myself enough room to the right. I'll just write them as a seam. 2 times 3 times 2 times 3. That's my 36. $48. I got a 2 and a 3. And another 2. And I need 2 more 2s and I don't have them, so I gotta make more columns. And finally, for 60, we had 2 times 3 times 2 times 5.
Yeah, I do like the column.
So I'll do the GCF above it. Maybe that'll make it a little easier to read. The columns that are full, I'm gonna move up. 2 times 3 times 2 is 12. This is really handy when you're trying to add fractions with these denominators.
See, I didn't understand with just 2 numbers because I was like, you can do that in your head, but as soon as you put 3 down there, I was like, yeah.
Yeah, it falls out pretty easy, right?
Yeah, that table worked out really well.
And so LCM, we just pull down one of each column. And it's kind of ugly, but well, let's see what we can get. I see a 2 times 5. I'm going to start with that bad boy. 2 times 5 is 10. And I'm going to put the 3 2's together. 3 2's multiply together to make 8. And the 2 3's multiply together to make 9. So the 8 comes from the single underline, the 9 comes from the double underline. And now 8 times 9 is 72. And so 720.
No.
I'm gonna check my key, make sure it works.
Sure, lock me in.
Okay, nice.
It's even better when you're trying to add fractions with different denominators. Table's even more magical.
I was about to say, I was having to do that in another class, and I was like, really having to think about it, and that table probably would have helped me, probably kill that class out.
So before I show you how to add fractions like that, maybe we need to talk about what fractions are. Just to make sure everybody's on the same page.
Those are the things with like the decimal point, right?
What?
Fraction.
They turn into, you can write them as decimal points.
Joke.
Everybody get that? It's not, it takes a while, right? It's not like a fast thing, but Bob over here could have been doing this shit on his calculator forever and never gotten it.
Well,
He would have gotten it eventually.
I would have had to add the paper, not actually.
Right,
But yeah, just sitting on the calculator wouldn't help me.
right. So let's talk about fractions. Egg carton. Egg carton is a good example. Or ice cube tray, if you are familiar with ice cube trays, you don't have a refrigerator or freezer that makes ice cubes on its own. Egg carton comes where there's 2 rows of 6. So there's 12 eggs, we know that. 12 eggs total.
Not a baker's dozen.
No, we don't have baker's dozen of eggs.
They should.
Let's say I've eaten 2 of the eggs.
Scrambled, fried.
Usually fried.
Which one? Over easy?
Yeah, over medium. It's a little runny, but not
Almost,
enough that I'm
yeah.
wearing it when I fucking eat it. You know what I mean?
Yeah.
I get in arguments over spaghetti on this shit. Long noodle spaghetti is messy as
I don't know. My dad doesn't break those noodles up and I'm like, you're an asshole. Break
Right.
those bits.
either break it up or use something like elbow macaroni. So that when you're
Yeah.
eating the, because like. Spaghetti sauce on any
I don't
form of
wanna be
pasta
rolling my
tastes the
quarter
fucking
through.
same, regardless of pasta shape. But the noodles, you fucking, that whips all over your fucking cheek and you're wearing it, it's messy.
Better you have to like sit there to eat it all proper, like you're in the 1800s, like spinning. the
Right.
fork around.
And even then, it takes too long that way.
Exactly.
If you use like elbow macaroni and just put the spaghetti sauce over it, you can shovel that shit fast and never get it on your face.
Yeah.
My wife is a huge advocate of long fucking spaghetti. Every once in a while, I was telling her, every once in a while, she like, I want to make it this way. I know you like macaroni or like a spiral noodle or something. And I was telling her the other day, you know, every time you do it and you tell me we're gonna do the long spaghetti day, it's like, all right, this is the day I'm not gonna enjoy dinner.
Yeah, because you're just gonna be watching.
Right. And it doesn't, long spaghetti noodles the sauce doesn't stick well to it.
Really?
Macaroni noodles, they're fucking hollow. They catch sauce in them.
Yeah.
So macaroni noodles or spiral noodles have the grooves that catches sauce. You can put spaghetti sauce
So you're
over,
eating flavor, not just.
yeah, you're not just eating pasta
Yeah.
with just a tiny. You can make spaghetti sauce right if you have like paste or something to make
I
it
was gonna say,
thicker.
my dad makes it like homemade instead of the jars, because
Yeah, you gotta make it thick. And that way it'll stick to the noodle, but, all right, so back to fragments. So if I want to talk about how many eggs I've eaten out of the carton, I can write this as a fraction. We have the fraction, we have a fraction bar. And mathematicians like to call this one numerator. And this one denominator. And the only reason I'm telling you this is because the homework probably uses these words. I don't care for them. They're the top and the bottom.
I was gonna say, yeah.
So this is like math jargon. Cafes don't like math jargon if you can avoid it. Top and bottom. So I will say top and bottom. The bottom is your total possible.
Or you're full. Right? I'd be,
I mean,
I don't know what way to say.
like if I had the whole carton,
I mean, I guess, but it's your. I know there's.
I don't know where you're going with this, so maybe figure it out. So in this case, for the eggs, it's 12. It doesn't matter how many I've eaten, there's 12 eggs in a carton possible. A normal carton, let's not go with the 18.
Cindy Williams from Laverne and Shirley died at 75.
You were too young to know who that is.
You've never watched Laverne and Shirley?
I've seen it.
Oh, okay.
I'm surprised you have.
No, I got old parents.
Top is the value you're talking about. So for me, I was talking about eggs eaten. And that would be 2. So my fraction of eggs eaten. Is 2 over 12. I'm getting there. I want to get the main gist of this stuff down first. Now, how many eggs have I not eaten?
8.
You can't
Oh,
count.
sorry, 12. No,
10. If you're not sure and you've drawn a picture, you can count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
I don't know my numbers past 10.
So eggs left is 10. And so fraction of eggs remaining. I'm off the fucking screen. Why does it start? That's so lame. Like this doesn't go up any higher. And it doesn't hit the white area. Like there's a square of white on here. The fucking camera does not hit the white area.
It's kind of, why not like give you a reference as to where you're gonna actually see?
Right, so let's see. How much counts more than this? So there's like this much on the screen, like the white box that is off, yeah. How about you move up?
I mean, there's a brief one, she's not here today.
Like the idea, like, I can put less on the screen
It's
if
hard
I
to
zoom
say,
in.
you said to keep moving it, so we can't like.
Right, that's why I avoid it, but I can. She's like, nope, I need the exact center of the room.
I was gonna say, yeah.
So fraction
Can we
of,
also say 2 out of 12 or 8 out of 12?
say that again?
Can we say like 2 out of 12?
Yeah, I
or
was
8
not
out
gonna-
of 12?
I was gonna.
Yes. So another way of saying this is 2 out of 12. Or we say 2, and then we write the bottom one like we're talking about streets, like first street, second street. 12s,
2/12.
2/12. I guess we would never have first on here. 2 firsts is doesn't. 2 out of 1 is a whole number. So 2/12. So the fraction of eggs remaining is 10 over 12.
And
10 out of 12. 10 over 12. 10/12.
unless a book or a test specifies any one of those will work,
Yeah,
for you at least.
well, I'm gonna ask you to probably reduce. But we haven't
Well,
done
okay, I was
that.
gonna say, but you know what I mean, like word form or.
I wouldn't ask you to write in words, that's. I'm never gonna ask you to write
Oh, you
numbers in
won't?
words now.
Oh, I love you.
Maybe one problem on the first test, just so you have practice writing checks. Like how you write a number on a check.
Yeah,
All right, so if I add up eggs eaten and eggs remaining, or eggs left, let's look at the fraction. I know what the total, well, we can do the total here first. 2 plus 10 is 12.
you can go over it.
Nope. I don't think we did. So if I look at the fraction form. How we add fractions, if I've got 2 over 12 plus 10 over 12. If I wanted to write this 12 over here as a fraction, it would be the 12 on top. And I know there was 12 possible eggs. So if I'm adding them together, this is what I get. I should have the total that I have eaten or left over the total possible. And then these are the two things that I was talking about individually. Now, I haven't told you how to do adding fractions, but if you notice,
They're the same on
the bottoms are the same. And so that's part of it.
you kind of have.
And 12 is the same as 2 plus 10, right? So I get 12 over 12.
Number over the belt.
So adding fractions. Where the bottom is the same. This is a must. Bottom is the same. Just add the tops. And use the same bottom. Dork. Now, if I didn't take any of the eggs out of the carton, I still have 12 eggs in there, right? If I didn't take any eggs out, I would have this 12/12 as a fraction. As long as I don't break any eggs on the way home. So I wouldn't tell you I had 12 eggs out of the carton left. I wouldn't tell you I had 12 out of 12 eggs. I would just say I had one carton, right?
Well, I mean,
Unless you like want to be elusive.
I mean, or you could have the 18 carton.
So this is just one carton. One carton of 12. Jackass. He's a jackass.
Where the bag on.
And what's 12 divided by 12?
Learn this one.
It's 1. That is not a coincidence. The fraction bar represents division.
Could be divided.
And yet I don't think we turn them into decimals yet in this chapter. I don't think we do. I think we do in chapter 3.
What the? It's dumb.
But I'll talk about it later on.
Yeah.
If we've got time. If anything, it's gonna be Wednesday.
It correlates so well. though.
That's the very next chapter.
Yeah.
So let's see, what else can we talk about? Let's talk about like if we had an 18 carton of eggs. And we get home, but our refrigerator, the egg rack, like in your refrigerator door, there's often an egg rack thing there. It's only got room for like a 12-pack. So let's say I had I take an 18-pack, take 18 eggs.
Home with you.
Let's see, that's 1, 2, 3, 4, 5, 6. And I have a leftover carton.
What's
I got 2 leftover buckets. I've got 2 leftover cartons.
Yeah, because the first 18 rack didn't fit in. Why would you only have like 6? But just in.
They sell half cartons like that too.
They do.
Yeah, they have you can buy
I've
6
seen
eggs.
like the big old like the square ones, like the 36.
You can buy 6 eggs. You can buy half a 12. So if I wanted to take these 18 eggs, like these are all here, I could put 12 of them in here. And the other 6 would have to go in this one. Now, if I don't want to, if I want to say how many cartons do I have?
Use for in total.
Eggs. The 12-pack style. What was your question?
Same, you answered.
Okay. I think this might be the best presentation I've ever given on fractions the way I'm doing it. I like how this is
Yeah,
falling
no, I like the.
This is going apart really well. Because we're about to hit mixed numbers. And then we're going to talk about reduction because this sets up for reduction really well. I'm not going to say I have 12 out of 12 eggs and 6 out of 12 eggs. That's stupid, right? No one says that. I'm going to say I have this one's the whole carton. 12/12 was 1. And this one, I could say it's 6/12. But really, would I say 6/12 or does that just look like half a carton? I've got one row filled up, the other row isn't filled. I've only got half of it.
Okay, I got a question, but why would you want to say have over 6/12? I know why, but just why would you?
Okay, so we got like that, that's where I was gonna go with it first. So I could say I have 1 carton and 6/12 of a carton.
That's kind of ugly. Isn't it?
That's ugly and long. No one says this.
No. Well, what do they say?
So rather than saying 6/12, I want to describe it in a better way because that's you've never heard someone say 6/12 ever. This is the same as 1/2.
But we only get that because what, both of those are divided by 3.
Even better. I'll get there. I would say I have one verbally. I would say I have 1.5 cartons.
And also using the visual.
I'm off the damn picture again. This is why I hate zooming out
I know.
or zooming in. You guys are like, I don't know what the fuck you're looking at. You're not on the screen. No one tells me I'm not on the screen. You guys let me know with that brow. Let me pause now that it's all on the fucking screen. If you're gonna make me have a zoom in, you need to tell me when my shit ain't on the screen.
I can see it.
Now,
I mean,
you couldn't see it then.
Well,
I'll do a better job. I'm sorry, it's Bob's job.
No, you
It's not rough.
It's her job. She wanted me to zoom in. Yeah, I'm just fucking with you. All right, so I would say I have 1.5 cartons. That's something you've heard people say. So how do I get from 6/12 to 1/2? No. Okay, go for it.
3?
No,
Divided by 3?
that's one way. So an easy way to get there is to write the factors.
Oh,
6 is 2 times 3.
correct. 'Cause
12 is 2 times 2 times 3.
you couldn't always do that if it was 56 and 154.
Yes, you could.
I mean, my way of just doing it.
Oh, yeah.
You have to do that, so my.
Well,
preference-
you may not be able, 154 is a shitty number.
I was about to say, I just screwed you over with that.
Yeah, it's only 2 and 77. 2, 11, and 7. Fucking shitty products. Okay. So if you break it up into those factors we did, you can cross out the number if it appears on top and bottom. Replace it with 1. Notice I've got 1 2 on top, 2 2s on bottom. I only cancel out 1 of the 2s on bottom. I can do the same thing with the 3.
Oh. Next time, write it with that space because that's the only thing that made it click from my head.
Okay. So Bob was saying, if I put that table, do it in the table format, probably do the denominator first. And then line up the stuff on top.
Yeah. Cause I could look at that top one and be like, how did you do that? But then I look at that bottom one and I'd be like, oh, you just skipped 2.
This one, the bottom one is an easier way to do it.
Yeah.
So, but the important part is you replace them with 1s. The top is now 1 times 1. The bottom is 1 times 2 times 1.
I think that's a cool way to do it. I've just never seen it done with a table.
So I get a 1 on top and I get a 2 on bottom. If you do it with the table, same thing, but you've now got them stacked over each other and you can cross them out. I strongly recommend putting the 1s in. A lot of people skip this. A lot of people skip writing 1s, they just cross them off. But the problem is, if I cross them all off and I don't put the 1s in, what does it look like I have left on top?
It looks like you got 2/3 or just say something.
No, if I cross off the 2 and the 3 and I don't put 1s, what does it look like I've got left on top? Nothing. So it looks like a 0. It's not a 0. So maybe put the 1s in. So this is called reducing to the least
Or common denominator.
'No, I don't know if I want to use that in this.
I mean, that's what it is, though. You can only go as far as no, you can't go, because you can only go as far as either prime,
There's a fucking word for it. I don't know what it is. I can't think of it.
meaning the local.
Reducing the lowest terms. That's it.
Really?
Yeah,
That's the best they can.
fucking lame. I know.
Dumb.
Something else to note here, 6 and 12. 6 over 12, not sorry, 6 and 12. 6 over 12 and 1 over 2. We just showed that they equal each other. These are called equivalent fractions. I'm not going to use that word, but if the book says equivalent fractions, that's what they're talking about.
And what that simply means is you multiply both by 6 and you get same fraction. Or sorry, you multiply 1/2 by 6, you get the same fraction.
Yes. In fact, what Mason was just saying, he said, notice this. If I take this 1/2 and I multiply by 6 and 6, I got to do it on top and bottom. I get 6 over 12. The reason why we want to do it on top and bottom is, what is 6 divided by 6?
1.
1. So all I've really done is what I've done is 1/2 times 1.
But the only way to actually do
Which
that
is-
with fractions is make it so that you actually have a 1.
Yes, the important thing is to know is I didn't change the value,
You don't need the denominator to be the same.
but I don't need the denominator to be the same. This is how,
That's what separates fractions. Sorry, that's what separates fractions, addition and subtraction from multiplication.
fractions with different bottoms.
What do you mean by add up with fractions of different bottom?
136 plus 148 plus 160.
Oh, okay. Oh, you're gonna go with that.
I'll start with the smaller one first.
Oh,
Let's start with the 28 and 35 first. Let me show you, give you an example. Let's say I have 3 28s and I want to add 4 35ths.
That 3's got a big old booty on
It's got a big old, because I started to write it as a 2.
it.
Then my 3 got back.
Maybe got that.
Got the whole bakery.
I'm over here fucking up my shit. 1, 2, 3, 4, 5. So how can I do this? Let's put our table back. We had 28
And 35.
and 35. And we said this was 7 times 2 times 2. This was 7 times 5.
Half an inch?
There.
There we go. All right.
Being about
And so I'm putting our table back up. I want to do, so make the table with the bottoms. You see it even now, it is glorious, isn't it? It's fucking glorious.
I love that. I can't believe you thought about it in the shower, because I mean, the shower is the best place to think, in my opinion. Like, I'll spend 30 minutes in the shower just on accident.
So we said the lowest common denominator was this. Or at least we said LCM.
Yeah.
When we're doing fractions, it's called the least common denominator.
But LCD and LCM technically mean the same thing in the sense of if you're only looking at the bottom number.
And so you'll see LCD, which is really just saying do the LCM of the bottom. And we got this was 14 times 10, which was 140. So I know my bottom is going to have, I'll do it down here. I know my bottom is going to have a 140 on it. What I want to do is I want to write these fractions as equivalent fractions that have a 140 on bottom, so that I can add them up.
But keep going. I want to see this if you answer my question.
So, how do I do that? Well, Mason was saying we want to multiply by one number over the same number, and we can get a higher number on bottom. I can make this 20 over 140 if I multiply by the right number. The right number is the hole in the graph.
Yeah, it's 5, okay.
The hole in the graph is 5. So I'm going to multiply this first number by 5 over 5. 5 times 28, if you work it out, is 140. The top is going to be 5 times 3. I'll just leave it as 5 times 3. The 35 is missing both of these. That's 2 times 2, which is 4. So I can multiply this one by 4 over 4.
Now I know what you mean by the graph is. The graph.
The fucking table is. I don't know that I can say the word I wanted to say right here. That's like teach you.
Bitching, that's all.
Bitching is good. I can use bit. I don't mind using bitch. So I'm going to put the 4 times 4 here. The 35 times 4 is still 140. So remember when we said is we can add these together, I can put these all together. I can do 5 times 3 plus 4 times 4.
I mean, it makes it so beautiful. You can almost do all that math in your head right there. Like it's all in the times table.
So 5 times 3 is 15. And 4 times 4 is 16. And if I add these up, this is 31 over 140.
You should have done 12 times 20.
Why?
Well, because then it would be just be 240. Because 12 times 2 plus 0.
Why do I want 240?
Right? Wouldn't that be
So the question is,
not multiple.
is this in lowest terms?
Yeah. You can't get 31, it's a prime number.
It is. The way you can check though, is you got to do this whole factored form thing we did on this last one. Like the 6/12ths, you got to kind of do this. But we already know the bottom.
Here, just write those numbers again.
The bottom is the numbers we already had. Don't refactor it. Just pull that shit down. What multiplies together to make 31?
Nothing.
Just 1 and 31. So nothing cancels out. So 31 out of 140 or over 140 or 31 140th. This is the lowest value, lowest term. Yeah.
Can you potentially do an example where in the very end it cancels out?
Yeah. I was hoping this one did, but I winged the numbers.
I know.
Let's say, shit. Let's say it was 32 over 140,
That's what I like.
not 31. Because I think this is easier to do than trying to set up the example ahead of time.
Oh, wait.
So if I were going to do this, the 32 over 140,
How would you attempt that?
what?
Just like, what would be your best way to simplify the 140 or the 32 first?
Well, 140, I already know the values. 140 is the values up here.
Oh, true. Yeah, you just.
So I'm going to use the values I have from the chart.
And then that just simplifies it.
Now 32, we can factor. 32 is 8 times 4. And this is 2 times 2 times 2, and 4 is 2 times 2.
So just basically.
So I've got 2 and 2 here, and to put it in the format that Bob likes. These two will cancel together, leaving ones. These two will cancel together, leaving ones.
What are your openings?
What I'm left with on top, I can ignore the ones as long as there's other numbers present. I have 2 times 2 times 2 left on top. On the bottom, I have the 7 and the 5. So 32 over 140 simplifies to 8 over 35. That's another word we use, simplifies. Yeah.
So the big difference would be, when would you recommend this method before the guessing check? Like,
when you can't do it in your head.
when you can't do it in your head, yes. As soon as you have to whip out a calculator, you say, split it up like that.
It's easy, yeah.
Because I mean, that made those numbers completely computable by thinking about it.
So, let's kick this up a notch. Let's use the numbers we had before. 36, 48, and 36, 48, and 60. I know where the numbers. I want to say we got 720. Yeah, we did. So let's say we're just going to add up 1 over 36 plus 5 over 48 plus we'll just go with 1 over 60. No need to make it crazy. It's already crazy with 3 fractions, right?
What are you trying to find again?
Trying to add these 3 fractions together. Sometimes you need to add fractions of different values when like if you're doing construction and you have 3/8 of an inch and you need to add 4/32 of an inch or 5/32 of an inch, you don't know how far that is unless you do this.
Only nice part about like measurements and stuff is that it's a lot more easier to memorize, but in terms of math, same principle.
Right. So if we do our table thing, we're going to do the bottoms again. 6s with 36 is 2 times 2 times 3 times 3. 48 had
2 times 2 times 2 times 3
2 times 2 times 2.
times 2 times.
And then I had another 2 and a single 3. And 60 was 2 times 3 and 2 times 5. Now, I recommend, especially if you need the greatest common factor, always make sure to stack up the 2s. Like if just do them in order. I probably should. I didn't do that here. Amateur up here.
I mean, you were doing it way better in my head because that looked right to me. So.
And we saw that this gave us 2 times 2 times 3 times 3.
Which would be also.
And this went to 720 when we did it.
I like the little dookie thing that you did with the 412.
I did the
Like that.
10 and I did the 8. And then I did the 9.
Oh,
8 times 9 times 10.
that's way better, ain't it?
Left to right is not usually the best way, the easiest way to do it.
No.
So I know I can get a denominator of 720. The question is, what do I got to multiply by? The 36 is missing these values. 2 times 2 times 5. 2 times 5 is 10, times another 2 is 20. This one is missing 20 over 20.
Wait, what do you mean by that?
If I want to get a common denominator of 1 or 720.
Oh, you mean by multiplying?
Yeah. So I'm going to multiply by the
okay.
20 over 20.
So in order to find the another factor to help get you to that least common multiple, you just fill in the rest of the graph.
You fill in the holes in that row. And so we'll fill in the holes for row 48. The hole in the 48 is a 3 and a 5.
So just to clarify, the numbers that are in red are the numbers that you would multiply to the top and the bottom to get the bottom to match 720 and the top to be equivalent.
Yes. Numbers in red were missing. If I fill in the missing values in a row, I can figure out what to multiply the top and bottom by.
I'm not annoying anyone, right, or asking questions?
This was a good question. I don't know that I was explaining it clearly.
Okay. Just because if I assume I have a question about it, someone else might.
That is an excellent assumption. I was telling my wife, I think I got the first day of class, I got a kid that's falling asleep in my class. He's gonna be my problem. He's gonna be my problem student. And no, you were the student that participates the most, which is good.
It's good if I don't participate, I'll probably be sleeping exactly like I did in the first class, so I mean.
And you learned something today.
Yeah, no, I mean, I did, I mean, that's awesome. Never knew that could be that easy.
So the 48 is 3 times 5. And I'm gonna leave it to as 3 times 5. I'll show you. We can put 15 if you want. It's 15.
The only reason why he did that is because he knows what 5 times 5 is, and that means 25. 25 times 3 is 75.
Yes,
If you do that math,
it's easier to do.
If you do it your way that you were thinking, you just need to calculate.
Look
You're
at
doing it correct.
fucking Bob is like a fucking FA whisperer. So I knew I had to multiply by 5. That I could do the 15. But I recognize that if I left it as 5 times 3 times 5. This is 3 times 25. And 25 is a quarter. And I know how much 3/4 is. That's 75. So if I leave, that's easier for me to do in my head other than 5 times 15.
He's kind of not lazy.
I am.
He's smart enough to where he doesn't have to do the calculator.
I try to avoid using a calculator at all possible
I mean, if you're a
because it
teacher,
slows me down.
it's kind of bad.
Let's be honest, it will, calculators, you have to pull it out, you have to pull out your cell phone to find the app, it slows you down. When like 5 times 15, I could do it in my head, but I'm gonna do it a lot slower.
Yeah, you'd have to break it up like I was looking into hours.
I would do 5 times 10 and then 5 times 5. But. Okay, let's finish the graph. What do I need to multiply the 60 by? It's missing this
3
value and those values.
So 6.
Nope,
No. 3. That's 2.
there's 2 2s there. I
Oh,
crossed that one.
Oh, you crossed out that one. Sorry. Well,
So 3 times 2 times 2 is 12. I might as well do the 12 because the top is 1. What I didn't write down is I need to do the 15 on bottom here. So I'm gonna grab the stuff in pairs or sets. I got 20 times 1 from the first one. I've got 5 times 3 times 5 from the second one. And I've got 1 times 12 from the third set. We just figured out the 5 times 3 times 5 was 75. That's the only one that's challenging me. Adding these up just takes a little time. 20 plus 75 is 95.
108.
95 plus
No,
10 is 105, and then another 2 is 107. The bottom is 720.
107 is not divisible by anything, so that's your piece.
It's not divisible by 2 because it's not even. The numbers don't add up to a multiple of 3, so that doesn't work. It doesn't end in a 0 or 5, so it's not a 5.
They do add up to an 8 though.
That doesn't mean anything.
No.
And it doesn't divide by 7. So if there is a higher prime number, if there's a higher thing that divides into it, I don't think so. But a way to check. How high do I gotta go on prime numbers until I can go, nope, no more divide into it?
I mean, I know that because 9 times 12 is 108. Oh, no, what's 108 again?
Only check primes up to the square root. The square, 100 square root of 100 is 10. Square root, if we wanted 11 squared in here is 121. So, like, I only need to go up till I get to 11 as a prime number. 11 doesn't go into it. Nothing else goes into it. I don't need to check higher prime numbers because nothing else is gonna go into it. Yeah,
You just doing that because the number kind of itself is wouldn't be a prime number.
yeah,
Cause I was about to say, if it's small enough that you can just go 9 times 12 is 108 and then else is gonna be up to that.
right. Or you can Google prime numbers and check. That's a good way to do it too.
But on a test, technically,
Yeah, yeah, on a test you can't do it, but I'm trying to teach you skills for the real world.
yeah, well, in the real world, yeah, Google is my best friend.
So this does not simplify. Top is prime, so I don't need to write out the bottom, but I could if I want.
How would you pronounce that? 107 out of 7/20?
Yeah. Or I would probably say 107 over 720. 7/20 sounds funny.
Yeah.
All right, so this was all using fractions, but earlier we had like the 1 and 1/2 cartons. We said that earlier. This is called a mixed fraction. Or a mixed number.
Why is that called a mixed fraction exactly?
Because it's got a whole number plus a fraction. So it's mixed.
How would you rewrite that?
So if I wanted to get rid of it,
And what would that call it if you get rid of it?
I'm getting there. So 1 and 1/2 like that is the same thing as 1 plus 1/2. And so how I can get rid of it, so it's just a fraction, is I can take this denominator and multiply this number by top over bottom like that. We're gonna get a common denominator. That's what these things over here are called, common denominators. Common bottom.
But I'm a little confused. How do you multiply 2 times 2 times 1? Just theoretically, if 1 was a different number.
Okay, jackass, I'm getting there, but it's a good question. Let me finish with this example first. So 2/2 times 1 is just 2/2, and then I got 1/2. And now I can do what we were saying earlier, add up the top and bottom. Add up the tops, leaving the bottom alone. 3/2, this is called an improper fraction.
And that is
Because the top is larger than the bottom. Whereas 1/2 is called a proper fraction, because it's the other way around. The bottom is bigger. Now,
on a normal test, what would you look at? See? Or I guess in a real world situation, what would you see?
usually in a real world situation, you would see a mixed number for what you're probably doing. But working with a mixed number is not as easy as I'm about to go into.
Because sometimes when you go to multiplication.
Multiplying mixed numbers is a bitch without going to improper fractions. Now, Mason had a good question. What if this was like 3.5? Well, I got 3 plus 1/2. And I said to take this denominator and multiply the first number by it. But what do I do in this case? When I have a whole number times a fraction, what I can do is I can take the whole number and put it on top, and on the bottom put a 1.
Why can't you do that?
Because 3 divided by 1 is still 3. So any whole number can be written as a fraction over 1. Which leads to a really good question. How do I multiply fractions? I was doing it up here. I fucking completely bypassed that discussion. For multiplying fractions, multiply the top separately from the bottom, and then do the same on bottom. So multiply the bottom two. I kind of glossed over that when I was getting the common denominator. I meant to do multiplying fractions first.
And I don't get it.
So for this case, I had 2 halves, 2 over 2 times 3 over 1. This turns into 2 times 3 over 2 times 1. Which is 6 over 2. Yeah.
I could do maybe how to simplify that fraction of that last one.
We're not simplifying it yet. Here I would just do division. Because remember, we were doing 3 plus 1/2. So I just did the 3 here. So I still need to add the 1/2. And now we're back to getting a common, keeping the common denominator. 6 plus 1 is 7 halves. So adding and subtracting are the same way. Keep the bottom the same. Add, subtract the top, depending on what side there is, sign there is.
But division, yeah.
We haven't done division yet. We'll get in there. For multiplying, the bottom changes also. This is the important difference. So add and subtract, the bottom stays the same. On multiplying, the bottom changes. You're multiplying it together. Earlier, we had 3/28. And I multiplied by 5 over 5. What I did is I said 5 times 3 on top, 5 times 28 on bottom. I did this with all the little fractions that we did earlier. 5 times 3 was 15. 5 times 28 was 140. Using the table, I was able to speed this up and not use a calculator. Back a little bit, I don't know, a little while ago. So that's how we can convert mixed numbers to improper fractions. To multiply. Or divide. I haven't covered division yet. But I want to cover the other things we'll do with mixed numbers, like add and subtract mixed numbers. All right, so let's talk about adding mixed numbers, adding and subtracting mixed numbers. Let's say I want to add 1 3/4 plus 4. And. Say 4 3/4. Okay, so the best way about going about adding and subtracting mixed numbers is add the whole numbers first. Then add the fractions with a common bottom. Common denominator is what they're called. So if they don't have a common bottom, you have to turn it into that first. Then if you have an improper fraction, need to be written as mixed numbers. Sorry for that 8, that's my page number there. So like step 1, step 2, and this is like step 3, but you may not have a step 3. The small level pumps it, whatever. So adding the whole numbers, I've got this 1 and this 4. So 1 plus 4 is 5.
How do you know that? You sure?
I am positive.
Sounds like you're on your hand as well.
I can. I'm not going to teach you counting on your hand
You got me.
because that only goes up to 5 on one hand.
Right, toes.
No, you don't want to
Oh,
see
you don't
that.
have extra?
Now next part is add up the fractions. I've got 3/4 plus 3/4. 3/4 like this is the same thing as writing it like this. You'll see it written both ways.
This slash is fancy here. Correct?
The slashes makes it easier when you're like having it in text, like in writing. It's easier to keep it on one line. This is 3 plus 3/4, which is 6/4, right? What you want to do to get this 6, so I've got right now, I've got 5 and 6/4. But no one would ever say 5 and 6/4. This sounds silly.
Because it's a mixed number and it's improper.
Yes. So one way of doing the 6/4 is I can treat 6/4 as 4 plus 2/4.
Why would you do that?
Because if I do that, I can turn the 4 plus 2/4 into 4/4 plus 2/4.
What is that 4/4 turned into?
The 4/4 is a whole number, it turns into 1. This is the division part.
Oh, so this is where you add that 1 to the 5.
So what I'm going to do is the 5 and 6/4 is 5 plus 6/4, which is 5 plus the 4/4 plus the 2/4. This turns into a 1. And I've got 6 and 2/4. But we don't want to leave it as 2/4. You want to simplify it or reduce it to the smallest value.
Only because why?
Because you sound like an idiot if you don't. Right? No one wants to sound like an idiot. That is
Then
why
you'll say-
most students don't ask questions in class.
You'll say 4/8, and then people will be like, you mean 1/2?
To go out of your way to not look like an idiot. Most students will not ask a question and they have no idea what the fuck is going on, but they won't ask because they don't want to look stupid. And they usually don't know that other people in the room don't know what's going on either. And sometimes no one does, because the teacher's just off on a fucking random.
And that's why I'll ask the question, because,
Why can't it just be by 6 by 4?
ooh, that's a
You
good
could.
question, that's a good question, that's a great question.
6 divided by 4,
Here's the cool part about math, as long as you're dealing with algebra, there's about 3 to 4 different ways you could probably solve most problems.
now, most uses you're gonna do it, you would do this,
Yeah, but.
but we haven't covered turning the decimals yet.
But you're not wrong, at all.
Okay.
So doing 6 divided by 4, we'll do next.
I was gonna
Wednesday.
say, could you go quickly do 6 divided by 4?
6 divided by 4 is,
So she understands.
you're doing 4 going into 6, you get a 1. Subtract the 4, I get 2. I got 1 plus 2/4. Is 1 and 2/4. Or if you did it with a calculator, you're gonna get 1.5.
But what is 0.5? Everybody
And
knows
0.5 is
right?
1/2. This is
1/2.
1 and 1/2. So do the reduction thing on the 2/4.
That's why he shows that part, because if you're working with bigger numbers, I agree with you. I mean, you look at 6 divided by 4, I mean, that's pretty dang easy to look at, but if you were working with what? 24 divided by
10.
10, yeah, look at that, and it's a lot harder of a number to deal with in your head like that. So it's a lot easier if you were to separate it much like Professor Henry. So.
Sometimes working with the fractions, keeping it in the fraction form is helpful if you're gonna do more shit with it.
But if you were to just end right there, do exactly what you did, because I agree with you, it's 100% easier.
So- I could have 6 and 1/2 as my answer.
If you know a bigger number, if you kind of understand maybe why it would be
Or
necessary.
6.5.
Just do one with like 2 numbers on the bottom and top, that way it's.
I'm gonna have- give me a second.
And I'm not as good at the math. 4836, do that. Ooh. Oh, that's good.
I'm not gonna finish chapter 2 today.
Screw it.
I am not gonna get through the fucking 19 chapters I want to get through in this class, so I need to figure out where I can
Yes, you will.
trim the fat. I don't know that I can.
You will though.
I think it might get easier, but I need to be
Because
very
like
slow.
certain parts like this, like the fundamentals of math really need to be covered. And then the rest of math will be way easier for everyone
Right.
else in the class.
So let's follow what we did here. The first thing we did was add the whole numbers. 4 plus 2 is 6. Second thing we did is we added the fractions. 15 over 16 plus 3 over 4. Yes,
But in order to add, what should we do?
we can't add them as they are, can we? Because the bottom isn't the same. So we need to make the bottoms the same. You can do the table.
Someone else answered beside me. What's 16 divided by 4?
That's the short way. Rather than making the table faster than tables sometimes.
As long as you know your times tables and they're within that times tables, you can do what I just did. But if they're over the times tables, explain what you would do.
Faster than the table is just take the bigger number and divide by the other one and see if it goes in. 16 divided by 4 is 4, which means this number is missing 4 over 4.
However, if you could not do it in the times tables, show us with those numbers, how would you do that?
I would do the table I was telling you about.
Does everyone understand how we got those multiples?
16 is 4 times 4. And these are 2 times 2. And so 2 times 2 times 2 times 2 is 16.
Here's all on a random person. Who knows the missing number is right there? By the 4. Who knows it? You should say it. What's 2 times 2? Come on. 4? All right.
I gotta let Mason fucking teach the class. I'm just gonna get paid to watch him do this shit. This is 2 times 2. It's the missing holes. That's what's missing. That's how I got the 4.
I just don't want you guys to be scared. I mean, I don't know a single one of you, but I'm talking the entire time, so do not be afraid to just say something. You have a question, say it.
Yeah, don't let Mason run his mouth the whole time.
Yeah, I know.
Cut it off.
I'm pretty annoying, so if you want to cut me off or shut me up.
I know why he's here. His fucking parents threw him out of the house. So go take a class. I don't care if you need it.
I mean, pretty much, I mean, I needed 12 units to become a full-time student, so this shit is free for me, so, I mean, this is the perfect class.
All right, so if I do that, remember we do the multiply the tops together and we multiply the bottoms together.
What would that be? Someone else answer besides me. Come on. Someone. Quick, besides me, what's your name? What's your name? What's your name? Yes, I'm talking to you. What's your
You're
name?
scaring me.
Okay, amazing.
Down with it.
All right, nice to meet you. But what is your name?
Bertha.
Wait,
Bertha, yeah.
Bertha, okay. Bertha. What is 3 times 4?
Thought like that.
What is 3 times 4?
12 and 16.
Yeah, you're right. Perfect. I know you know it.
All right, this
But
is,
I wouldn't
this
even
is
know-
why you don't do that.
I know.
You see
but
her reaction?
I understand.
This is why I don't go. Every once in a while, if I know everybody's names, I will do it once in a while. I tend to only do it if someone's fucking sleeping or ignoring me and I know they're on their phone.
I mean,
I
that's.
I call them on their shit by going, what's the next step? But otherwise, I
She's
will,
following along and she's confused, but I know for a fact that Bertha knows exactly what she's talking about. And she's only confused because she's not talking with you. And I know for a fact she knows.
you got 10 minutes left. Let me get as much done as I can. So we add these together, right? Jumping the gun.
I was just saying.
And that gets me 27 over 16.
Both going to.
Yes,
Still make that smaller.
yes. Because why? Why can I make this small?
Because the top is larger than the bottom.
Nailed it.
Bam.
So, I think of the division thing you were saying. Let's divide the 16 into the 27. It goes in 1 time. I subtract and I get 11 as a remainder. Which means the 27 over 16 can be written as this one up here. Becomes that one right there. And then I'm going to take this number and it's going to be my top. And I'm just going to keep the same denominator, the same bottom. So 27 over 16 turns into 1 and 11/16. Just doing some division. The reason why this works is I'm taking the 27 over 16 and I'm doing this 16 and this 11. I'm saying this is 16 plus 11 over 16. And then I'm splitting it up like this. So that's why it works. I think the division thing is the easiest thing to do. But we weren't done. So we had the 6 up here. And this 1 and 16 is here. So 6 plus 1 is 7, and I've got 7 and 11/16. That would be 15 over 16 plus 2 and 3/4. Page 9. It's the same thing with subtraction. You're just putting subtraction here and you're doing each of these things with subtraction. Oh, fractions and decimal, they are in here. Shit. I'll do decimals to fractions and back again on Wednesday. How do we compare fractions? We've got more to do on chapter 2 that we'll do on Wednesday. And I'll finish with this idea real quick. We'll be up 5 minutes early.
No way.
This is easy. I promise this is easy.
You split?
I do. I want to compare 1/4 and 5/16. Which is bigger? Is that your, are you guessing, are you staying as factor, or where are you going?
Saying it because the higher it is, the smaller it is.
Okay, that's a good idea. Let's see if it works out. So one thing we could do is I could get a common denominator. I could multiply this by 4/4. We just showed 4 and 16 had a common denominator like this. So this would be 4/16 and 5/16. So clearly the 5/16 is bigger than the 4/16 because we compare tops. As long as the bottom is the same. That is one way of doing it, and if you do it that way, you won't go wrong, and it'll make you better at finding these common denominators, stuff like that. There is another way, and I'll show you the other way because it can be fascinating. Another way of comparing 1/4 and 5/16 is doing something called cross multiplying. I'm going to take the 4 and multiply it by the 5. And I'm going towards the direction of the top. This side will be 20, 4 times 5. I will take this one and multiply that one's top. 1 times 16 is 16. $20 is bigger than 16. Which means 1/4 is less, 5/16 is bigger than 1/4. The problem is you got to make sure you stick with where you're going. I'm taking the 4 and I moved it up to the 5. So the 20 is below the 5/16. Yeah.
After you're done with the second. It's not, it doesn't. It's like, okay.
So let me give you guys one to check.
You want
I'm
to,
deliberately using 3/9 because I
you want to check which one's bigger?
yeah, which is bigger? Compare these.
Shouldn't use bigger numbers.
What? Why? How many of you can do this in your head? I can, but I'm not going to. Because it takes longer to do in my head than just write this down. I'm going to do that same thing I did before. I'm going to take the 7 and I'm going to multiply it by the 3, and I get a 21 right here. 7 times 3. I will take the 9 times the 2. Now an 18. Because it's 9 times 2. So since 21 is larger than 18, 3/9 is larger than 2/7.
Okay. I need to start back.
You're right. If I use larger numbers, we just have to get out our fucking calculator. That's a pain in the ass. What's the point using larger numbers?
No, but I mean, do use your method, but in your head. It's pretty easy.
Even then, most of the people aren't going to do the table or things. A lot of people aren't ready for doing math in their head. Or do you want to do the math in your head, Bertha?
I'm not either.
You are that smart. You're just not practicing.
As I said, you just know, all I know is the multiple table. You're smarter than me, just like, I only know.
Not only that, so sometimes when they have bigger numbers, you're not gonna see that number.
I want to make that clear. If you don't do the math in your head, that doesn't mean you're not capable of it. It also does not mean you're not smart. It just means you're not practicing it.
Yeah, it just doesn't mean you have it memorized.
I go quickly with this, and I bet Mason has practiced it too. Practice doing math in your head.
Oh, yeah, it's only because of the way like your teacher did it, they didn't do like timetable,
You can do it in this class when you're doing your homework.
but it's not that fun.
For some numbers where they're smaller, start with smaller numbers like these. Try to do the math in your head first, figure out the answer, like picture a whiteboard in your head. Picture the whiteboard, picture doing the operations, see what you get. And then actually do it by hand and see if you get the same thing. That's how you get better at doing math in your head.
It also might sound a little silly, but you could get online, you can look up multiple tables, like timetables. And like the problems, like most classes, like in third grade, give you like, I don't know, 35 of them. You could look those up and just time yourself and see if you can get faster.